welcome back to the Deep Dive. You know, there is this persistent myth in the tech world.
I think I know where you're going with this.
It's the idea that if you buy enough smart bulbs, stick a Wi-Fi chip in your coffee maker, and, connect your thermostat to your phone, you have officially digitized.
Right. I bought an Alexa, so I'm living in the future syndrome. It's fun, but it's not exactly an industrial revolution.
Exactly. But today we are looking at a stack of training materials that essentially says that is not IoT. That is just gadgets. We are digging into the comprehensive curriculum from Favoriot. And honestly, this is massive. It's a roadmap that attempts to take someone from I have never touched a circuit board all the way to
I am designing the strategic infrastructure for a smart city.
It's a huge span.
It is. And what I love about this source material is that it tackles the single biggest problem in the industry right now, the deployment gap.
Okay, define that for us. Because I think a lot of executives feel this pain without knowing the name for it.
It's the gap between knowing what the Internet of Things is conceptually, fridges talking to phones, sensors in the soil,
right,
and actually having the skills to make 1,000 distinct sensors survive in a hot, dusty factory, talk to a cloud server securely, and then generate a report that a CEO actually cares about.
That's the mission today. We're going to walk through this curriculum from the fundamental wiring through that messy middle layer of gateways up to the brain-melting AI, and finally,
the business strategy.
Yep, I'm ready to get my hands dirty on the tech side. I have to say, the robotics track in this material looks particularly cool. It moves beyond just sensing into acting.
And I want to grill you on the business side because, as we know, you can have the smartest robot in the world, but if it doesn't solve a real problem, it's just a remarkably expensive toy.
Fair enough.
So let's start at ground zero, the IoT fundamentals course. This is a 2-day deep dive.
Okay.
If I walk into this room knowing nothing, maybe I'm a product manager or a junior dev, what's the first barrier they break down?
The first barrier is structure. Before they even let you touch a wire or write a line of code, they hammer home the Favoriot platform hierarchy.
Which sounds incredibly dry. Hierarchy? Sounds like corporate paperwork.
It sounds dry. It's the difference between a working system and a complete disaster.
Okay, how so?
See, most beginners just dump data into a database. They build what we call a data swamp. It's messy, it's unsearchable, totally unstructured.
Right.
Favoriot teaches a strict taxonomy. Project, application, group, device.
Okay, so let's make that concrete. It's like having a filing cabinet versus just a pile of papers on the floor.
Exactly. If you're monitoring a smart city, your project is the city. Your application might be streetlights.
Got it.
The group could be the North District, and the device is lamppost number 402.
And if you don't get that taxonomy right on day one, you can never, ever scale.
You can manage 10 devices with a messy system. You can't manage 10,000.
Okay, so we have the filing system. Now, let's talk hardware. I see they're using the Hibiscus Sense Kit and the Arduino IDE.
Yes, the classics. The Arduino IDE is the industry standard for coding microcontrollers.
And the Hibiscus Sense is great because it combines multiple sensors, humidity, temperature, pressure all on one board.
But the real insight here isn't the hardware itself. It's the language used to make it speak.
You're talking about the protocols.
Right. The curriculum spends a lot of time on REST API versus MQTT.
I feel like this is a constant debate in the tech world. For the listener who manages strategy, why does this distinction matter? I mean, why can't I just use standard web traffic?
You can, but it's really inefficient. Think of a REST API like sending a certified letter.
Okay.
You write it, you mail it, the server opens it, reads it, and then sends a letter back saying, got it. It's reliable, but it's heavy. It takes time and energy.
And if I'm a battery-powered sensor on a water pipe in the middle of nowhere, I do not have the energy to write letters all day.
Exactly. And that's why the course emphasizes MQTT. It's more like a text message group chat.
Much more lightweight.
Incredibly lightweight. The device wakes up, chirps, temperature is 80, and goes right back to sleep. It uses a publish-subscribe model.
So that's a key takeaway. If you're building for speed and battery, which, let's be honest, most IoT projects are, you go MQTT.
And they don't just lecture on this. The materials highlight using a tool called Postman.
Oh, I've heard developers swear by Postman.
It's a simulation tool. Before you deploy your hardware, you use Postman to mimic the data transmission.
So you're essentially spoofing the device to make sure the letter arrives at the right address.
It teaches a vital engineering discipline. Verify before you deploy. Because once that sensor is cemented into a sidewalk, you can't easily debug it.
Which brings us to the payoff of the fundamentals course, The dashboard.
The hello world moment. You breathe on the sensor, the humidity spikes, and a line on your laptop screen just goes up.
It sounds simple, but that visual feedback loop from physical reality to a digital graph is usually the moment the light bulb turns on for people.
It stops being code, and it starts being reality.
It is, but honestly, that's the easy part. Reading data is easy. The real world is messy.
And that's a perfect segue to the Advanced Internet of Things course. This is a 3-day track.
Right.
And looking at the syllabus, the difficulty curve spikes here. We stop talking about clean, easy connections and start talking about the gateway.
Ah, the gateway. The unsung hero of industrial IoT. In the fundamentals course, your device probably has Wi-Fi. It talks directly to the cloud.
Simple.
But in a factory or an oil rig, you have legacy machines that speak ancient languages.
They aren't on Wi-Fi. They're on serial cables from the 1990s.
Exactly. They speak TCP, UDP, or some proprietary serial protocol. The gateway is the translator.
So it stands in the middle, takes that gibberish from the machine, translates it into MQTT, and then shoots it up to the cloud.
This is often called the brownfield problem in business. Greenfield is building new. Brownfield is trying to make old stuff smart.
And trust me, there is a lot more brownfield out there than greenfield.
And to handle that translation, the course introduces my absolute favorite tool in this space, Node-RED.
I've seen this. It looked like a flow chart, right?
Yes, it's low-code development. Instead of writing thousands of lines of Python, you have a canvas. You drag a box that says input, serial port. You drag a wire to a box that says function, convert to JSON. You drag another wire to output, MQTT.
So you are visually drawing the logic of the data flow.
Precisely. It democratizes the complex logic. It means a process engineer who understands the machine but isn't a coder can actually see what the data is doing.
But the advanced course introduces another massive shift. In the beginning, we were just listening to the device. Now we start talking back.
Control.
RPC, remote procedure call. This is where IoT gets both risky and powerful.
Explain how that works in this context.
Okay, so your dashboard shows the engine is overheating.
Yeah.
In the basic version, you just see a red light.
Right, an alert.
In the advanced version, you have a button on your web app that says activate cooling fan. You click it. That signal goes from the cloud down to the gateway to the device and physically triggers a relay to turn on the fan.
That's a massive security implication, by the way, if you can turn it on.
A hacker can turn it off, which is why the architecture matters so much.
Mm-hmm.
But the capstone here is building that custom web application. You stop using the generic Favoriot dashboard and build your own command center that handles both historical data analysis and real-time control.
So you've gone from a hobbyist making a line go up to an engineer building a command and control center.
Correct. But it's still just automation. It's human sees red light, human presses button.
It's not smart yet. It's just obedient.
Exactly. To make it smart, we have to go to the third track, mastering AIoT.
Artificial intelligence of things. This is your playground.
This is where the magic happens. The course switches hardware here. We move from the microcontroller to the Jetson Nano.
For those who don't know, the Jetson is basically a supercomputer the size of a credit card, right?
It's a GPU-powered edge computer, and the key word there is edge.
Why is that distinction, cloud versus edge, so critical here?
Bandwidth and latency. Imagine you have a camera watching a conveyor belt for defects.
Yeah.
If you send 4K video to the cloud to be analyzed,
your Wi-Fi bill will be enormous.
And it will be way too slow. The Jetson Nano analyzes the video on the device. It does the thinking locally.
So it only sends the result. Defect detected, not the whole video stream.
Exactly. And the curriculum dives deep here. They cover supervised learning, where you teach the machine, this is an apple, this is a pear.
Okay.
And unsupervised learning, where the machine looks at a mountain of data and says, I found a weird pattern here that you didn't tell me of.
And I see they're using Jupyter Notebooks and scikit-learn. These are real data science tools. This isn't a Mickey Mouse version of AI.
No, they're building regression models.
Give us a so what for a regression model in IoT. Why does a factory manager care about regression?
Predictive maintenance. A simple sensor says vibration is high. A regression model looks at the rate of change in vibration over the last month, correlates it with temperature, and predicts. The bearing will fail in 72 hours.
That is the holy grail for manufacturing. Risk anticipation. You fix it before it breaks.
That saves millions in downtime.
They even touch on neural network CNNs for image recognition, RNNs for time series data, and Jan's generative adversarial networks. That is cutting-edge stuff.
Now, alongside this high-level AI, there's a robotics track, the Robotics Internet of Things.
The fun stuff?
It sounds fun, but knowing this curriculum, I assume it's not just playing with RC cars.
Not at all. They use the Robo Pico kit here, powered by the Raspberry Pi Pico W.
The W stands for wireless. This is crucial.
It is. You aren't building a remote control car where you hold the joystick. You're building an autonomous agent.
I see.
You're building a robot that reads its own sensors, light-dependent resistors, air quality sensors, decides where to move based on that data, and then reports back to the mothership via MQTT.
It's a full feedback loop. Sense, acts, act, report.
Using CircuitPython and the Thonny IDE, you program that logic. It's a microcosm of a warehouse logistics robot. It's an Amazon Kiva robot in miniature.
So it's checking air quality. If it's bad, it moves to a safe zone and alerts the central system.
Exactly.
Okay, so we have built the robot. It's smart. It can predict its own death via AI. It can navigate the room. But now I have to put my business hat on.
Please do.
Because often this is where the project dies. The engineers build something incredible, and the business side says, great, but how does this make money?
And Favoriot actually has a course for this, IoT for business professionals.
Led by Dr. Mazlan Abbas, the CEO. This is a one-day intensive, and the target audience changes completely. No more Python.
Oh.
Now we're talking to the C-suite.
So what's the core message to the executives?
It's shifting from technology-centric to outcome-based. Engineers love to talk about the how, the MQTT, the nodes, the wiring.
Right.
Business leaders need to talk about the why, and they use the 7Ms framework.
Run us through that.
Man, machine, material, method, money, and a couple of other, depending on the version. It's a checklist.
Yeah.
How does this sensor optimize manpower? Does it reduce material waste? Does it save money?
If you can't answer those questions, you don't have a product. You have a science experiment.
And they use the IoT business model canvas.
I'm a big fan of the standard business model canvas, but the IoT version is tricky. You have to map out, are you selling the device or are you selling the data?
That's the classic shift from CapEx, capital expenditure, to OpEx, operating expense.
Right. Rolls-Royce is the famous example. They stopped selling jet engines. They started selling uptime. You pay for the hours the engine is running. If it breaks, Rolls-Royce loses money. That creates a massive incentive for them to use IoT to predict failures.
That is the outcome economy. You aren't buying a drill, you are buying holes. This course teaches executives how to structure that kind of contract.
That's a huge shift in thinking.
It is. And the Favoriot curriculum scales this up one last time. From the device, to the factory, to the smart city.
This is the 2-day Smart Cities course.
And what I appreciate here is that they don't just talk about generic futurism. They ground it in the Malaysia Smart City indicators. They talk about local versus global challenges.
Context is everything. A smart city in Scandinavia has to deal with heating and snow removal.
Sure.
A smart city in Kuala Lumpur has to deal with monsoons, heat dissipation, and completely different traffic patterns.
And they tie in the other big buzzwords, blockchain and ESG.
Environmental, social, and governance.
This is huge right now. If a city claims it's green, how do you prove it? You need IoT sensors, verifying air quality and carbon emissions, and maybe blockchain to create an immutable record of that data so nobody can fudge the numbers.
It adds trust to the data.
But the most valuable part of this course, from what I can see, is the failure analysis.
Yes. They analyze why smart cities crash and burn.
And why do they?
Usually, silos.
The traffic department doesn't talk to the energy department, which doesn't talk to the waste management department.
So you end up with 5 different smart systems that are stupidly disconnected.
The data swamp returns, just on a citywide scale.
Exactly. So the course focuses on interoperability and key success factors to avoid that trap.
You know, looking at this entire stack, from the 2-day fundamentals to the smart city strategy, it feels like they are trying to build a full-stack innovator.
That's a great term for it.
Because usually these skills are segregated. You go to a coding boot camp to learn Python. You go to an MBA program to learn the business canvas. You go to a vendor certification to learn the gateway.
But the problem is, the developer who doesn't understand the business model builds features nobody pays for.
And the executive who doesn't understand the gateway promises things that are physically impossible.
This curriculum tries to bridge that language barrier.
It allows the CEO and the engineer to actually have a productive meeting. And that is where innovation actually happens, in that room where both sides understand the constraints.
Which brings me to a thought. Looking at the decision intelligence aspect of the AI track, we are moving toward a world where machines aren't just reporting, they are deciding.
We touched on this with a fan example, but play that out. Where does this go?
If we successfully build this AIoT ecosystem, if your toaster, your car, and the city grid are all running on these predictive models, they stop asking for permission.
Go on.
Imagine your dishwasher. The vibration sensor detects a bearing is wearing out. The AI predicts failure in 2 weeks. It doesn't beep at you.
Okay.
It uses its own wallet connected via blockchain to order the part. It schedules a technician, and you only find out when the guy knocks on your door.
That completely changes the concept of ownership. You aren't the owner anymore, you're just the host. The machine manages itself.
And the IoT for Business course hints at this. In an outcome-based world, you don't want to know about the bearing. You just want clean dishes.
But it also means we are building a world of background commerce. Machines trading with machines via MQTT, spending our money to maintain our lifestyle.
It's incredibly efficient.
And vaguely terrifying.
That's the future.
Well, if you want to be the one designing that future and ensuring it's the efficient version and not the terrifying Skynet version, you probably need to understand how it works.
Start with the fundamentals. Don't skip the hierarchy.
And for the business folks listening, I'd recommend looking at the readiness checklist mentioned in the executive course. Before you spend $1 million on sensors, check if you actually have the 7 M's in place to use them.
A checklist is always cheaper than a failed pilot project.
Words to live by. Thanks for diving deep with us into the Favoriot curriculum. It's a dense stack, but it's the blueprint for the next decade of infrastructure.
Until next time, keep your data structured and your sensors clean. See you in the next deep dive.